Hey everyone, I wanted to spend just a little bit of time talking about strings today. So we're going to have just a little mini lesson on strings. So I'll be working in the interactive shell from BlueJ. So I've opened up a project that I've just called strings. We'll do one little example code as well. I don't want to have this available here. Let's start with making a string. So a string is an object, and it's a special kind of object. It's an immutable object, meaning that changes that we do to it are not permanent. Any change you do to a string returns a new string instead. So let's make a string called word. Now, it's an object, so we know that when you create an object variable, you start with the type. My type is of type string. And then you usually have to say something like new and then the class name. Well, there are some special classes, including all the wrapper classes, integer, capital I integer, capital D double, capital B boolean, those wrapper classes, and string where you don't have to do that. You can just create it just straight. So let's say we're doing the word tomorrow. Okay. All right. So I've got a word here, and if I say word plus soon. Okay. Now, if I do this, you're going to see they get an error, not a statement, because I'm not actually assigning it to anything. So that's not going to work. We can't say word plus is soon, but I can say word plus equals is soon, and you're going to see that word is now going to say tomorrow is soon. But what's really happening here is we're actually creating a brand new string that has tomorrow, and we're adding is soon to it through concatenation, and then restoring that back into word. Okay. So let's take a look at another way. How can we show that this is immutable? Well, if I say word dot, here's our first method for today. Strings have methods because they're objects. So we're going to say to uppercase. Now, if I don't put a semicolon on that, it'll actually show me what I did. Notice that to uppercase makes all the letters uppercase. But notice that the word didn't change. If I actually want the word to change because it's immutable, I have to do something like that. Now I've made it permanent. And I could, of course, undo that with to lowercase. But that's what I mean by saying it's immutable, that any action that you perform on that string is temporary unless you assign it back into itself. Okay? All right. Let's take a look at a few more methods from the string class. We don't actually have to know that many. We need to know compare to, index of, and substring. So let's start with compare to. Word dot compare to. Compare to is a method that many different types of objects have that allow us to compare two together. If I have another word, let's call this other word, and I'm going to make it yesterday. Okay? Oops, I forgot to type it. String other word equals yesterday. Well, then I cannot do something like this. That's not going to work. Error, bad operating times for binary operator. In fact, we should never try and use the less than for any kind of objects, even integers. If they're integer objects, you must use compare to. What I can do is word.compare to other word. And what we're promised is that this will be some sort of number. It will be 0 if the two words are exactly the same. If the first word comes before the second word alphabetically, then it'll be a negative number. And if the first word comes before the second number, it'll be a positive number. It happens by subtracting what are called their Unicode values, the code values for the numbers associated with each one of those letters. But we don't need to worry about that too much right now. We just need to know that if I put in any kind of thing like that, I'm going to get a negative number because A comes before C. And it will continue as well with ties. I could have them tie for the first letter, but then that second letter, X, comes a lot after B. That's why it's a negative 22. If I flip it around and I put something like, something like that, then I'm going to get a positive number because this comes after that. So just remember, A dot compare to B is a number less than 0 if A comes before B. All right? All right, let's take a look at another method that we need to know. We need to know index of. So that's kind of let's take a look at what word was again. Word was tomorrow is soon. So if I say dot index of, and I give it that, it's going to tell me the index for where this appears. Well, here's index 0 is the T. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it'll be the first occurrence of it. So if I say word.index of O, what will that be? Well, I think you can guess that it'll be a 1. There's several O's, but it's going to be the first index that it occurs at. What happens if I put in a capital O? Well, it's case sensitive, so this is not going to return a new index. So what it's promised to return an int, so it returns a negative number. So we can use index of to say if one string contains another. If it's a negative number, then we know that it doesn't. So for example, I'm trying to see if this word contains my name. I can ask it that. It tells me a negative number. I know that it doesn't contain that word. So that's how index of works. The last method we really need to talk about is the substring method. So let's bring up word again. The substring method slices the word into different substrings. So if I say word.substring, I need to supply it with two different indices. The first index is where I start at, and the second index is the last index, so like a 12. So that would be 0, 1, 2, 3, 4. So this R, 4, 5, 6, 7, 8, 9, 10, 11. And it doesn't take the S because the 12 is where you stop and you don't include it. So it includes the first number, not the second one. If I want to get the first letter, then I need to say something like that. If I want to get the last letter, it's a little more challenging. Let's talk a little bit. How would I get, say, the second letter through the end of the word? So I say 1, comma, word.substring.length. Sorry, not word.length. Dot length is another method we need to know. Dot length tells you how many letters are in the word. Similar to length of array, but it's a method. It has parentheses. So you'll notice that's going to give me second letter all the way through to the end. Okay? So what to do? There's another way to do that, though, that Java has supplied us with another form of substring that you also need to know. And that is if I just give it one number, it'll start at that index and go through the entire thing. It will automatically call word.substring 3, comma, word.length. And you can see how that works. So how would I get the last letter? Like that. Remember, it'll include the word.length. The last index in a word is the length minus 1. So it'll include that letter, and it will go to the end of the word, which is just that last little bitty letter. So one of the things you need to be comfortable with doing is looping through a word one at a time. So how would I do that? Well, if I wrote a for loop, I could do that. So let's take a look. We're going to make just a new class, and I'll just call this class example. So public class example. I'll just say public static void test. Okay. So I'm going to make a string called words. Hello. Goodbye. How are you? All right, something boring like that, right? So say I want to loop through this one letter at a time and maybe count the number of H's. So I could say int H's equals 0. I could say for int I equals 0. I less than words dot length with parentheses, I plus plus. Then I can get a substring. I can say if words dot substring, and here's how I get the ith letter of a word. You're going to do this a lot. I, comma, I plus 1. If I wanted 2 letters at a time, I'd do I to I plus 2, but I would need to make sure that I subtract 1 from words dot length. So if you're going to go 2 letters long, you need to go, minus O there. But for us, that's fine. Dot equals H. Remember, we don't say equals equals, just like we don't use less than or equal to. These are less than signs. These are Boolean, these are objects, so you have to use dot equals and dot compare to. Then we'll just make those words go up by 1. And at the end of our loop, we can just print them out. So that's one thing we could do. Let's test that right quick. 2, which is correct. Okay, one other important technique that you need to have down for AP Computer Science is how to convert numbers and peel them off. So let's say we had an integer of, let's say we had int num is equal to, let's say, 1, 2, 3, 4, 5, 6, 7. Okay? And what I want to do is I want to create a string that contains each one of these numbers separated with a space. Okay, so how could I do that? How could I peel these numbers off? I could put them in an array even that's equal to the size of that. How would I know how big an array? Well, that would, then I guess you would have to know how many digits this is, and you could get that like this: int length equals num plus quote quote dot length. That would tell you how long it is if you wanted to make an array. But let's not do that. Let's just make a string. So I'm going to say string nums, okay? And our goal is to get it look like that, because we're going to take that number and do this. So here's how we're going to do it. We're going to loop through this number, and we're going to simply divide out and mod out. That's what we're going to do. So we're going to say while num is greater than 0. So I'll say nums plus equals, oh, I forgot to give it an initial value, so nums will equal quote quote. So I'll say nums plus equals num mod 10, and then I'll say num equals num divided by 10. So by dividing this number by 10, I'm throwing that away. Remember, this will do integer division. And then at the end, let's print out our nums. String system.out.println nums. And let's add a space in between each one. So let's test that out. And notice what it did. It did 1, 2, 3, 4, 5, 6, 7, but it's backwards. Well, that's because you can see that I'm string concatenating. The first number I'm going to do is 7. And then it's going to do it again, and it's going to peel off this number 6. Remember, modding by 10 always gets you the last digit. Dividing by 10 removes the last digit. So how can we make it to where it's not backwards? Well, we could just go and try and reverse the string, but it's actually really not necessary. Just instead of doing plus equals, say nums equals number mod 10 plus a space plus num. Anytime you want to just reverse a string, you just take one letter at a time and change the way it orders it. Nums plus equals means nums plus that. But if I say that plus, nums, then it's going to keep it in the right order. There we go. And so we can do that with a lot of different ways to format numbers and things like that. We could even add commas if we need to, things like that in the right place. We could have a, maybe I want to take that number and make a comma. So I'm going to say int place index. Okay, so I'll start with my place index. When it's 0, we don't do anything. When it's a 1, we don't do anything. Right? So then when it's a 2, we don't do anything. But when it's a 3, what we're going to do is we're going to add that number in a comma. So let's try that. Let's try doing this again. So we're going to make it a string, but we won't. I still need to make it a string, but I'll add just an empty quote. All right. And then I will say, I'll say if, let's see here. I'll say the if place index mod 3 is equal to 0, we're going to do something special. We're going to add that number, but we're also going to add a comma before it. So by saying place index mod 3, that means when 0 would be the 7, and then the 6 will be at 1, 5 will be at 2, 4 will be at 3. That's where that comma needs to be. And we need to make sure that we increase that that place index, right? That's going to help me know where to put commas. So let's give it a try. And so we get something that's, oops, not quite right. Let's take a look at that. Oh, you know what? We need to have, this is a little bit tricky. We need to make sure that it's not, place index is not equal 0, because we don't want that first comma there. We have 2, let's see here, nums mod 10. Oh, you know what? I forgot to do else. Else, sorry about that, y'all. I'm just making this up as I go along sometimes. All right, so if it's a number that, if place index is mod 3 and not the very first place index, which would also be mod 3 being 0, mean a multiple of 3, 0 is a multiple of 3, then we'll just go ahead and we'll put the comma. Otherwise, we'll just put the number and then we'll peel it off by 10. All right, that's better. Okay. Test that one more time, and hopefully we like the results. All right. Looks pretty cool, huh? All right. So that's it for me. You'll have a neat little project to do where you get to use a little bit of these techniques, but we'll be using a lot more string stuff as we go along. So